Thanks everyone for joining. We are really excited to have you here. And if you have ever dealt with traceability headaches in engineering, requirements living in one place, tests in another, change request falling through the cracks, today's session is for you. So we have got a packed agenda from digital engineering fundamentals to a live demo with DOORS, ARIS, Jira, MBSE, and even an industry case study. So let's dive in. Let me introduce quickly who you will be hearing from today. Joining me is Mohammad Daud Taj. Mohammad, would you like to give a quick introduction?
Hi everyone, and thanks for joining. I'm Daud from Nomad Germany. I will talk about our company a little bit later. I'm a DevSecOps engineer. I've been with the company for 6 years and helped lots of digital engineering threads come true.
Thanks, Mohammad. Excited to have you on the webinar. I am Aparna Garg, Director of Product and Marketing at OpsHub. I have 17 years of experience helping firms set up digital engineering, digital thread. And I work at the intersection of engineering tools and the teams that rely on them every day. What we have on our roadmap today, we'll kick off with digital engineering, what it really means and the challenges teams face right now. Then we will zoom into traceability across V model, why it matters, where it breaks down. And after that, we will explore different approaches to implement a digital thread. The fun part, we'll also do a demo. We'll play a demo recording. I'll do the live voiceover. In the demo, we will we'll connect DOORS with ARIS, MBSE tool, and Jira, so you can see how it looks in action. And we'll wrap up with an industry case study, real-world perspective on how this plays out at scale. So let's go. Mohammed?
So let's start off with what is digital engineering. Digital engineering, don't confuse it with digitization or digital transformation, is more a shift from a document-centric approach to a model-centric engineering approach, which means that you don't have your single source of truth in a single document like a PDF or Word document, but instead you have a living digital artifact like a model or a data set or a simulation. It's supposed to basically ensure that your full product lifecycle, from requirements to the final operations, are completely connected and traceable throughout the whole thread. So that's what a continuous digital thread is, with the core idea being that you can make decisions at any point in time, and those decisions are immediately visible on the other end of the V model. We will see the V model in a minute. Many of the viewers might have heard about MBSE tools, model-based system engineering tools, which basically require some kind of digital engineering with a single source of truth being MBSE. In the next slide, we will see what the driving needs are for digital engineering. Basically, modern systems nowadays have millions of requirements, thousands of interfaces, hundreds of suppliers, and just basically the complexity of that is not manageable with a Word or Excel, as many people try over and over. The supply chain complexity by itself is really, really difficult to track and trace. Many automotive users or customers know that very firsthand. Late stage defects need to be reduced as much as possible, since they are very, very costly. They can cost millions if you realize that you made a big error in your requirements when you're starting testing. Of course, you also have mandates and regulatory certificates like ASPICE in the automotive industry, or the Department of Defense, DODI, I forgot the full name. But most importantly, also, I'm sorry, what?
Did you mean DODI 5001?
Yes, yes. But most importantly, of course, you want your teams to be able to quickly work independently of other teams. So concurrency, basically you want parallel work in your teams to get quicker product life cycles, to get quicker results and be able to decide quicker. But basically that's where all the problems starts. In the next slide, we see that all teams start with so-called point solutions, where basically for specific problems, for specific disciplines, you choose specific tools. It most often starts with DOORS. For our example today, we are also starting with DOORS for the requirements. But afterwards, you have several other tools following the chain, like Rhapsody for the live data model, Jira for the software management, or MATLAB Simulink for simulations. Then later on, you have ALM, PLM, etc., etc. The list is basically infinitely long. And each tool comes with its own internal data model, its own ID schemes, its own user base usually also. And they don't really speak naturally to each other. So integration often relies on the engineers to manually import or write some brittle scripts or API adapters to connect all those tools. Also, you have a lot of licensing issues. Every single tool will need a new license. It all comes together with the promise of digital engineering being one authoritative model, but with the way traditional approaches work, you usually end up with multiple partially authoritative models, each taking care of their own little discipline. And you don't really have a full traceability across the whole product lifecycle. In a fragmented tool landscape like that, all your links are basically cross tool boundaries, which always are brittle and require manual fixing if you update anything lower down the line. If you don't do that, any link will silently go stale. Like you will never even realize it if you're not actively looking for it, that you're missing a back link from your test environment to your requirements engineering, which basically means you updated your architecture because in testing you realized that your approach doesn't work as you expect it to. So you would naturally have to update your requirements, but obviously the testing team is going to go ahead and take care of what they can do, which leaves the requirements silently go stale. Coverage gaps like that become invisible because you don't have native tools or utilities to ask, please show me every system requirement that has no verified test result. With that, the V model, as most of you probably know it, appears to be followed on paper, but the actual engineering decisions are untraced because they are poorly adopted in each specific discipline's mandatory authoritative model tool. Documents will say it is compliant, but the actual reality is not. This is not really just a process problem. It's a complete safety and liability problem in regulated domains, and completely breaks the digital thread connectivity. The V model itself fundamentally is a traceability contract. So every item on the left side, so from the stakeholder requirements to the architecture documents, must have a corresponding artifact on the right side. So the engineering artifacts, so test results, verification evidence, validation results, to close this loop. This essentially makes auditing time, this essentially makes auditing time become a crisis because teams on the right side have to manually reconstruct what the requirements on the left side were, and therefore end up often producing a snapshot that is already out of date by the moment they create it.
Very right, Mohammed.
Yes.
The traceability problem becomes a nightmare.
Yes, and on how to solve the traceability problem and how to approach this, a partner will now take over.
Yeah, so as you can see the diagram over here, it's if let's say design team is not just, they just don't need to interact with the architecture team, but also development team, also testing team. So on the left, we have got the definition side. On the right is the verification side. As Mohammed, you rightly highlighted, the key takeaway here is that the traceability across the V model isn't a nice to have, it's the foundation. All the dotted lines we see over here is how the traceability needs to be built. This is what gives us a high quality digital thread running underneath everything. Without it, every tool is just an island. So now the question is, how do you actually achieve this when the data lives in 5 or 6 or 10 different tools? So that's exactly what we'll tackle in, we'll talk about in next few slides. So this is one of the approach of implementing digital thread. It's also called centralized digital thread, centralized model. In this, and this is how most of the organizations try to solve the digital thread problem today. There is one central system that connects every tool. So it connects to PLM, DevOps, ITSM, CRM, MBSE, and all of this is feeding data into the central store. On paper, it makes sense. One place for all the data, one platform managing the thread. But in practice, it creates serious problems. First, the central store has to scale infinitely. It needs to hold data from every tool, every team. Second, engineers, all the engineers, all the people using these tools, they are forced to duplicate work by manually entering or manually triggering an action to enter the data into this central system, which doesn't serve their day-to-day needs. So they don't have really any motivation. An engineer or a developer won't have any motivation to feed the data into the central system or to take some action in their system manually to do so. And the third, which is combination of first and second, it creates a massive change resistance. Nobody wants to adopt another platform on top of the tools they already use. The core issue is here at the bottom, high overhead, and there is no real benefit for engineers doing the work. All the information stays logged in the central system for one team. This is not a digital thread. It is a digital silos with extra steps. Now here is the flip side, the federated approach to digital thread. Instead of forcing everyone into one central system, the federated approach lets each team keep their own tool and work in their own tool they already know. So all these systems, they stay in their place. The difference is the data moves, how the data moves between them. So it syncs bi-directionally with full traceability intact. So the data is syncing bi-directionally between QA and ALM tool. The data is syncing bi-directionally between ALM and ITSM, or PLM and requirements tool. This is just one, demo diagram or a sample diagram. It may look completely different in your environment. So by this way, we have decoupled the digital thread creation from its consumption. Engineers don't have to change how they work. They keep using their existing systems like they are using today. And the thread forms automatically with the OpsHub and knowmad mode running in the background. And now what are the benefits? Adoption goes way up because there is no training needed. Nobody is asked to learn a new system. Nobody is asked to learn a new process. A PLM user is working like they were working before. They are creating data like they were creating before. They don't need to take any additional step. Data quality improves because it is maintained in the tool where it was created. And by separating creation from the consumption of digital thread, that is reporting, analytics, every team gets access to the information they need. Right? So PLM teams, they need access to requirements, need access to design. They have that access in their tool. QA team, they need access to DevOps, they need access to ALM. They have that data in their tool. They don't need to go anywhere to see this data. So now this is the creation of the digital thread. Let's see how this looks from the consumption side. So this is a broader picture, or you can say a like bird's eye view of what the digital thread end-to-end looks like. On previous slide, we saw this part, creation part, where the engineers are working in their own tools and the data is synced bi-directionally. Now let's talk what happens on the what happens beyond, how the data or how the digital thread can be consumed. So let's walk through this diagram from bottom to top. At the bottom is the creation layer. We just had a bigger view of this layer in the previous slide. Sorry. The tools teams already use every day, PLM, ALM, DevOps, etc., etc. Data stays in these tools and nobody has to change how they work. In the middle, which is here, the data can flow into a relational database. So in relational database, you can create a graph structure, a related diagram, link structure, connecting product elements, BOM, test results, design elements, customer tickets, all enhanced and linked together. This is where the raw tool data becomes something greater than sum of its parts. In the tools, all this data is in their own tools. Relational database, it gets all this data together. And then at the top is the consumption layer. So there are intelligent hubs for, let's say, these are again some sample hubs. Like there is a dev hub, or let's say there is a change impact analysis hub, or there is an audit hub. And that is feeding into AI agents, dashboards, analytics. Now here's why the separation matters so much. Here we have separated digital thread creation from consumption. Creators and consumers have fundamentally different needs. Engineers need speed, accuracy in their native tools. They need best of the breed tools to do their day-to-day work. Managers, analysts, on the other hand, in their native tools, need aggregated, enriched cross-tool data. When these two concerns are tangled in one system, every optimization for one side compromises the other side. If I try to do something better for consumption, how do I consume the data? How do I create the report? I have to compromise how the data is created. But by separating them means creators stay fast and consumers get richer insights. No compromise on either ends. So what does this look like at a platform level? The Nomad mode and OpsHub offers a federated digital thread platform around 3 pillars. First is zero disruption for teams. No configuration changes in existing system. It is lightweight to roll out, so you don't need to install any plugin in the end systems. You don't need to ask engineers to take any additional step to create the digital thread. Engineers keep creating the data exactly they do today, and this is what drives adoption. So it's completely seamless. Second is high quality digital thread. So no manual steps to create it. Data syncs, no manual steps to create the thread itself. Team create the data as they do in the end systems, and data syncs automatically across the systems, and traceability stays accurate and reliable without anyone babysitting it. And the third is live intelligence and not snapshots. So purpose-built hubs for AI and analytics, incremental data flowing in real time, and insights during execution rather than after the fact. So this is one platform connecting every tool, every team, and every data point. Now let's see this in action. We would like to show a small demo recording for the in light of time. We have recorded the demo beforehand. So I'll play the demo recording and I'll do the live voiceover. So in this demo, we will show a digital thread created between a PLM tool, which for the demo purpose, we have taken ARIS. ARIS is integrated with Cameo using the custom connector, uh, which is the MBSE tool. And MBSE tool is integrated with IBM DOORS, which is the requirements tool. And PLM tool is also integrated with Jira. Jira in this scenario is used by the software development team. So this is again, once again, this is just a demo flow, a sample flow. It doesn't mean only this is possible. Give me a minute. I'll change the screen share and switch to the demo recording, the video. Meanwhile, if there are any questions, please feel free to drop us in chat. Okay, Mohammed, can you see my browser?
Yes.
Okay. Okay, awesome. So what we are seeing over here is ARIS interface, and this is standard vanilla ARIS. We have not done any customization. There is no plugin installed. The only thing OpsHub and Nomad mode will need is a service account so that we can connect to it. And everything we will see now in this demo is the user in that tool doing or taking an action. So let me start the recording. So we are in ARIS. We have already pre-created a CR requirement and a system requirement, and this is already there in Cameo. It is integrated using our custom connector. So here we are creating a change request, navigation unit performance update. The user has given title, description, and they are saving it. So it is saved. So once again, user, this is ARIS user working in ARIS just like they work usually. Okay. So we are back to Cameo, and Cameo we refreshed. So here is our change request that we just created in ARIS. And the engineer or the system architect in Cameo, they have pulled that change request into the model. So navigation unit performance update is a change request. The CR requirement was already there. What we will do is now this CR requirement was originally created in ARIS, but now in Cameo, the system architect is doing some update in the requirement. So they're changing status to pending approval. That means their work is done and they need approval now to close it, or if there is any feedback. So what this is enabling is, in addition to digital thread, it is also enabling near real-time cross-team collaboration. They don't need to do this collaboration over Slack or over emails anymore. They can just do it from the end systems. The system architect has now created a new CR requirement, system calibration software requirement, and they are now also creating a block requirement underneath that. So this is again system architect working in Cameo, just like how they do usually. Again, there is no plugin for the integration to happen. OpsHub is working in background. So there are background jobs running on a separate VM, not on Cameo, not on ARIS VM. It's running on a separate VM that is fetching data from these tools and integrating data as per configuration. Now we will create link. So we will say the change request is satisfied by both these two CR requirements. This is the link created. And we will say the CR requirement in turn is satisfied by the block requirement. So system architect will now commit the changes. This is the normal commit, how you commit in MBSE tool. There is no additional step required here. and they'll just are quickly validating the linkage matrix between model and between the requirements block and change request. So while architect is doing it, OpsHub is running in the background, and it using the APIs, it will connect the end systems to read the data and write the data. For the system architect or for ARIS user, it's completely seamless. They don't even know that there is something there that is getting the data. So ARIS user is now just refreshing the view, and here are the two CR requirements. One was there in ARIS already, and the one we created in Cameo just now. And they are pending approval. The status, as you can see, is pending approval in the last column. Now we go to DOORS. So in DOORS, the requirement manager needs to approve the requirement. So DOORS also, we see the whole hierarchy. This is a change request. And if we drill down, it goes to both the requirements in this change request. And if we further go down, then in these requirements, we will see the block requirements. So the whole hierarchy of change request, requirements, block requirement is created in DOORS as well. Now in DOORS, requirement manager is approving the both the requirements. That means the design is done. A Cameo team or system architect team can see in their own tool that it is approved. So they will mark it completed. So there is no email. All the information, all the message exchange is retained in the systems itself. I don't need to go to email. I don't need to go to Slack or Teams to send the message that I've done it. Please look into this. The systems will automatically send the notifications, and all the information exchange, all the details are there in the system itself. So system architect has now marked the status completed for navigation accuracy requirement. And now if we go to ARIS, we'll refresh it to here also, we can see for one requirement, status is changed to completed now. And this will now in ARIS, change request will be marked approved. This will now will go to Jira. So this is a signal for the dev team, for the software dev team, that the change request is approved, design is ready, so they can start the development. So here are both the requirements in Jira. So in the development team is marked. Let's pretend the work is done. So the fastest work ever done. So the requirement is completed. And ARIS also, the team will mark it completed. So this completes the demo recording. I know it was a little fast. If you want to see this same flow live, do reach out to us. We have this set up. We can show you the live demo. And I'll just change back to the PPT. Okay, yeah, so this is the flow we just saw. In ARIS, the requirement was created, a change request was created, then Cameo and ARIS team worked together to finalize the design. In DOORS, the requirement was approved. And once it was approved, the requirements went to Jira team for developing it. And once it was developed, finally in ARIS, everything was closed. Do let us know if you want to see this. I know if you want to see the demo recording, we can share the link with you in chat. Okay, moving forward. What happened? 1 second. Okay. So this is a sort of a pro tip or a bonus slide, you can say. Most engineering organizations are living in two worlds sometimes. They live in two worlds sometimes, sorry. Legacy teams have years of critical data and proven processes built around IBM DOORS. It's so proven that you don't want to touch anything because it's working. Meanwhile, the modern product teams are moving to next gen platforms like DOORS NG, Codebeamer, Polarian, JAMA. And traditionally, the assumption has been that one side has to give uh, either force the legacy teams to migrate or hold the migration teams back. Neither of it works. So the bidirectional sync engine from Nomad mode and OpsHub changes that entirely. It sort of connects both the worlds with full traceability without asking anyone to abandon their tools or learn a new interface or migrate the data. Each tool, that is a legacy tool and the modern tool, they remain authoritative. And what makes a real cultural shift possible is like there's no forced migration. Migrations fail because they create resistance, teams push back, there is timeline slip, data quality drops during the transition. With simultaneous operation, there is no big bang cutover. The legacy and modern systems run side by side, and adoption happens bottom up. So teams move when they are ready, not when a plan says they should. The result is the traceability that works across both the generations of tooling without the organizational pain that usually comes with modernization. So these are all the platforms that are currently supported. So we support like 70 plus platforms already across PLM, QA, requirements, database, project and portfolio management, build ITSM. And if you don't see your tool over here, it might be on our roadmap. Or let's say if you have a homegrown tool or any other commercial tool, even you can build your own connector and plug it into the platform. It's an integration platform, it's a digital thread platform. So once you plug in your own connector, the platform will enable you to sync that tool, your custom tool, with any of the tool we already support. So there is no need of point to point development. Mohammed, would you like to summarize the business benefits?
Yes.
Yes.
To summarize, the business benefits of getting a correct, the right approach of doing digital engineering will actually bring you reduced risk and higher quality, since you can catch defects and problems early when they are still cheap and easy to fix. Um, you obviously you have to ensure compliance and certification and general audit readiness, which you get with this approach. You reduce cost overall, since time is money, and speed is a given, since you can always work in parallel and basically the boring stuff is already automated. And of course, finally, you basically have a strategic competitive approach, which can hold with the classic tech industry standards that already follow these patterns.
Yeah, thanks, Mohammed. So let's wrap up. We also have a couple of questions in the chat that we'll take in some time. So this is the industry case study we were talking about. The customer is a leading global defense and aerospace prime. They had to. This is their phase one. So we are just getting started. There are many more projects and artifact types in the future phases. To begin with, they had to sort of create a thread between Windchill, IBM DOORS, and Jira for 4 projects and 10 artifact types. So the challenges were monthly painful CCB cycles. It was not real time, so it was a nightmare to get all the data together and get the CCB reports ready. There were brittle Python scripts to get these reports ready, which were uh, like
Hey,
which would require weeks of work. Yeah, sorry, Mohammed, you want to add?
I know, I just wanted to mention the word pain. Brittle Python scripts are pain.
Yes, yes, true. So there were like traceability gaps across the programs that needs to be reconciled month on month. There would be a team sitting just to do that. And with Nomad Mode and OpsHub Integration Manager, the real-time collaboration, just like how we saw in the demo right now, the real-time collaboration between the teams was enabled. The CCB cycles were automated, governed synchronization, full traceability was achieved between these tools, and a unified data layer was created. There is also a full case study of this on our website. So again, please feel free to DM us if you would like to learn more about this case study. Mohammed, would you like to talk about Nomad Mode?
Yes, of course. So Nomad Mood Germany, we are part of the Nomad Mood group, which is based in Spain. Obviously, Nomad Mood Germany is based in DACH region. Uh, we are a fairly small but growing company that has multiple years of experience of supporting mostly DACH region industry companies across all industry sectors, pretty much from automotive to defense and space and whatever you can think of. We build, we basically build and break down your existing environments and help you get the right tools for your actual use case and how, well, we train you on how to connect them for future use.
Okay, thanks, Mohammed. So about OpsHub, at our core, we are an intelligent federation platform. That means we unify enterprise systems into a trusted AI-ready digital backbone without asking anyone to rip out what they already have or to change their way of working. Three things that make OpsHub different. First is AI-ready intelligence. So we take the fragmented data scattered across tools and transform it into connected knowledge that AI co-pilots, AI agents need. Second is accelerating digital engineering, which was most of the webinar was about. So getting siloed systems, the data across siloed systems together, unifying them while preserving the contextual data. So like we saw in the demo, the whole traceability from change request to requirement to block requirement was preserved across ARIS, Cameo using the custom connector, the MBSE tool, and IBM DOORS. And the third is the non-disruptive tool modernization, which is sometimes organizations do need to move from a legacy to modern tool. So we enable them, make them move without any downtime. So together with Nomad Mode, Nomad Mode's deep implementation expertise across 150 plus enterprise projects, that's a powerful combination. And the platform and the hands-on experience to make it work in complex regulated environments. So that brings us to the end. And I want to thank every single one of you for spending this time with us today. Um, so let time to take some questions. There are some questions in the chat. Let me just read it. So the first question is, does it support the complex rich text format moving data from Polarian description to Jira description? So yes, it does. Polarian description is HTML or rich text, and whereas Jira is wiki. So we take care of bi-directional conversion while retaining the formatting, like the bullets, tables, colored text, all the font styling, including inline images, or if there are any user mentions or some other issue type is mentioned. And in addition to that, also we support add-ons like X-ray, Qmetry, Ziffer. So if you want to integrate test steps between Polarian and Jira, that also can be done. The next question is along the same lines. Do you take care of those OLE objects when syncing with Jira or other tools? So yes, we do handle OLE objects. So one of the motto of OpsHub and Nomad Mode is uh, we will be making more damage by integrating incomplete data than not integrating at all. So it is better not to integrate anything rather than integrating incomplete data. So our motto is to integrate complete data and give the user in the other tool the same view that other users are seeing. So OLE objects get synced as attachment in other systems. The other question, there's one more. So the question is, I see that OpsHub supports event or trigger based push to remote system, which is duplication of data. In a scenario, I have released work item in Polarian and want to link it to existing part. Does OpsHub UI based link creation so I can pick and choose the right path? So it is, so I think it is, the question is about maybe not replicating the data from Polarian to Team Center, but just linking it to a part. It can be done. So what can be done is instead of you can write that part link into the Team Center hyperlink. So Team Center has an area where you can create external links. So that is one way, but you would definitely like to understand why the duplication is not needed, because in this scenario, while it is possible, what happens is the Team Center user will have to understand, will need a login into Polarian. So it will double your license cost. It is better to, like, data cost is nothing. But if you want to give access to Polarian release or Polarian item to a Team Center user, it will incur, it will double the license cost basically. So we'll be happy to discuss this in more detail. And there are quite a few questions. I'll just take one more, and everyone else, sorry, we'll reach out to you over email. So the question is, can the tool connect Doors with Jira Cloud? Yes. So again, it can be done because all the communication is from the platform to the end system. So Jira Cloud will never initiate communication to OpsHub or Nomad mode. So OpsHub gets installed in on-premise, so it can access Doors and it can access Jira Cloud. So this way you don't even have to open the firewall to let an incoming connection in your network. Okay. So any other question that we are not able to take, we'll reach out to you over email. Meanwhile, feel free to reach out to either of us directly. So here is Mohammad's LinkedIn, and you can also connect with us through opshub.com or nomadmode.de. And sorry, yeah. Okay. Well, before we leave, let me leave you with the key takeaway, which is end-to-end traceability doesn't have to mean replacing the existing tools or forcing teams onto new platform. The federated approach to digital thread, this is where the data syncs bi-directionally with full traceability without incurring additional license cost. And the creation stays separate from consumption and adoption happens at each team space. That's how organizations actually get the digital thread right. So with that, thanks again, everyone, and enjoy the rest of your day.
Thanks, everyone. Have a good day.